Good morning, children. Welcome to the chemistry class. Good morning, children. Welcome to the chemistry class. We were discussing P block elements in our last class. In today's class, we would be discussing one of the important compounds of group 15, that is ammonia. It is actually the hydride of nitrogen. Ammonia is considered to be a hydride of nitrogen. Okay, so just see. The chemical formula of ammonia is NH3. The chemical formula of ammonia is NH3. In the laboratory, it is prepared by heating a mixture of slaked lime and ammonium chloride. If I take slaked lime and ammonium chloride and if I heat it strongly, then I will get this compound, calcium chloride, ammonia gas will come out, and water. And you all know ammonia has a characteristic pungent smell. Ammonia has a characteristic pungent smell. By that characteristic pungent smell, we can identify that the compound is ammonia. We can easily identify the compound is ammonia. Okay, so ammonia is obtained by heating a small amount of any of the ammonium salt. It is always preferable to take ammonium chloride, and one important characteristic of ammonium chloride is that ammonium chloride shows the process of sublimation. So when ammonium chloride is heated with calcium hydroxide, or that is called slaked lime, we get calcium chloride, ammonia gas is evolved, and water is also obtained. Another process we can perform is that we can take ammonium sulfate and heat it in presence of sodium hydroxide. What we get? We get ammonia gas, water, and sodium sulfate. We get ammonia gas, water, and sodium sulfate. Okay, these are the two methods by the laboratory preparation of ammonia, or these are the two methods by which we can prepare ammonia in the laboratory. Okay, I'm giving you 2 minutes time to just copy down these reactions. Okay. Okay, see, after that we have next method, that is the manufacture of ammonia. How is ammonia manufactured? Ammonia is manufactured by the Haber's process. See, just try to understand. Haber's process is a very important process. When the process was discovered, it was considered that one of the greatest discoveries of chemistry. It was considered as one of the greatest discoveries of chemistry because by this method we can prepare ammonia, and ammonia is such a compound which is important, essential ingredient It is the essential ingredient of all our fertilizer. Okay, so what we do, ammonia is generally manufactured by the Haber's process, which involves a direct combination of nitrogen hydrogen. So see, nitrogen and hydrogen is taken in a ratio 1:3, and this reaction for the Haber's process of the manufactured ammonia is actually temperature and pressure specific reaction. What is the meaning of temperature specific reaction? The meaning of temperature specific reaction is that this reaction, this reaction, this specific reaction, this specific reaction is actually dependent on a temperature of 450 to 500 degrees Celsius, and the pressure is taken 200 to 900 atmospheric pressure. So just try to understand the range of the temperature 450 to 500, and the pressure is 200 to 900 atmospheric pressure. We get ammonia. Okay, we get this compound that is called ammonia. And what is the heat enthalpy in the reaction is negative 46.1 kilojoule per mole. So this is actually the method by which we actually prepare ammonia. Okay, after that, you see, so I'm telling you once again, Haber's process was considered as one of the greatest discoveries of chemistry. In this Haber's process, we actually prepare ammonia, and method of preparation is that we take nitrogen hydrogen in the ratio 1:3, and the temperature is 450 to 500 degrees Celsius. Atmospheric pressure is 200 to 900 atmospheric pressure. And also another important thing that I want to share with you, that this reaction takes place in the presence of iron powder as the catalyst. Apart from it, we have molybdenum as the promoter. Okay, so these are the three major conditions. I'm repeating once again. This reaction is temperature specific. Temperature specific means that temperature is 450 to 500 degrees Celsius. The pressure is 200 to 800 atmospheric pressure, and the catalyst is iron powder. Apart from iron powder, what we see that in this reaction we have to use a promoter, and the promoter in this case is molybdenum. By this the reaction actually takes place. Okay, after that we have the next one, that is the properties of ammonia. What are the important properties of ammonia? The first important property I told you, that ammonia is a colorless pungent gas. Colorless pungent gas. I'm repeating it, the smell of ammonia is very characteristic. By the smell you can easily identify the gas. Okay, next important property is that it is extremely soluble in water. Its aqueous solution is weakly basic due to the formation of OH ion. Its aqueous solution is weakly basic due to the formation of OH ion. Okay, it forms OH ion, and hence it forms ammonium hydroxide. Okay, see the reaction ammonia plus water, it forms ammonium hydroxide. Ammonium hydroxide splits into ammonium ion and OH minus ion, right? It forms salts with acids. It can form salt like ammonium chloride, ammonium sulfate. So zinc sulfate plus ammonium hydroxide, it forms zinc hydroxide plus ammonium sulfate. Ferric chloride plus ammonium hydroxide, it forms Fe2O3.xH2O plus ammonium chloride. Fe2O3.xH2O plus ammonium chloride. The ammonia acts as a Lewis base due to the presence of lone pair of electrons. So ammonia acts as Lewis base due to the presence of lone pair of electrons on nitrogen. Hence it forms a number of complexes with metal ions. So this is a very specific reaction, that if I pass ammonium hydroxide to a copper salt, if we pass ammonium through a copper salt, first of all, it forms a pale blue precipitate. But if the process is repeated for a longer time, it forms a deep blue precipitate. Okay, deep blue precipitate because it forms a complex, and the name of this complex is tetramine copper sulfate. Okay, so just this is a very important type of reaction for analytical importance. Analytical importance means this specific reaction is of analytical importance because this specific reaction is of analytical importance, because in this reaction what actually happens, that when I pass ammonium hydroxide through a copper sulfate solution, first of all it forms a pale blue precipitate. Again, adding excess of ammonia, it forms a deep blue precipitate. So the formation of deep blue precipitate confirms the presence of copper, or I can say this is a identifying test of copper ion. This is a identifying test of copper ion. So is this part clear to you, children? I'm giving you 2 minutes time. Just copy down these reactions, okay? Please copy it. Okay, I hope you have copied it. See, after that, next reaction we have is whenever silver chloride salt is made to react with aqueous ammonia, it forms a colorless complex of diamine silver chloride. Okay, diamine silver chloride. So the first compound we have studied is ammonia. After the next compound we would start is nitric acid. See, nitric acid is commonly known by a name called aqua fortis. Nitric acid is commonly known by a name called aqua fortis. Okay. Now, what is laboratory method of preparation? In the laboratory, it can be prepared by simply heating either sodium nitrate or potassium nitrate. Either we take chai saltpeter or we take Bengal saltpeter. Okay, and we heat it with concentrated sulfuric acid in a glass retort. Mind it. Very, very important. This nitric acid is very much sensitive to other materials. So always we have take a glass apparatus. Okay. So what is the reaction? We are taking sodium nitrate. The sodium nitrate is made to react with sulfuric acid. We are getting sodium hydrogen sulfate as well as nitric acid. So this is how the reaction takes place. Okay. So we have taken sodium nitrate that is made to react with sulfuric acid, and what we get actually sodium hydrogen sulfate plus nitric acid. So this is the laboratory method for the preparation of nitric acid. So what we have sodium NaNO3 plus sulfuric acid, sodium hydrogen sulfate plus HNO3, sodium hydrogen sulfate plus HNO3. Okay. After that, we would discuss the manufacture of nitric acid by the Ostwald's process. What happens in the Ostwald's process? In the Ostwald process, what we do, the reaction involves the manufacture nitric acid as follows. First of all, we take, see, whenever we think of industrial method, one important point should come in your mind, that the reactants for this industrial process should be very much cheap. Okay, I'm repeating it once again. Whenever industrial method we have to manufacture, we will always think of a method by which we can manufacture it by a cheap method. Now, what is that cheap method of manufacture? The cheap method of manufacture is that the raw material should be cheap. In this case, what is the raw material? We have taken ammonia, which we can obtain from the Haber's process. We are taking oxygen from air, and we are reacting that in presence of platinum and rhodium gauze catalyst. Okay, and the temperature see, it is 500 Kelvin and 9 bar atmospheric pressure. 9 bar is the atmospheric pressure. See the reaction, we have taken ammonia that is made to react with oxygen which you obtain from air, and the catalyst in this case is platinum and rhodium gauze catalyst. The temperature is 500 Kelvin and the atmospheric pressure is 9 bar, right? What we get? We get NO plus water. We get nitric oxide plus water. This nitric oxide, which is neutral one, that is further oxidized nitrogen dioxide. Nitrogen dioxide is further reacted with water to give you nitric acid and NO. This NO which you obtain, it can be again recycled in the second process. So just try to understand the active or the utility of industrial process, or the benefit of an industrial process is that we should manufacture it in such a way so that there should be the cheapest method, there should be least amount of wastage, and third thing is that the method should be easy. So I'm telling you, for industrial method, three important things have to be noted down. The first important is that the method should be cheap. Second is the method should be easy. And third is the materials by which we have to manufacture it, that should be easily available. If these conditions are satisfied, then only we can move to the industrial method. Is this part clear to you now? So what have I done? I've taken ammonia, made it react with oxygen. What we get nitric oxide. This nitric oxide is a neutral one that is made to react with oxygen further to give nitrogen dioxide. This nitrogen dioxide on being reacted with water, that gives you nitric acid. If there is some unreacted nitric oxide left out, that can be recycled in the second stage, hence we can get nitric acid. Okay, is this part now clear to you? I'm giving you 2 minutes time. Just copy down the Ostwald process of manufacture of ammonia. After that, we move to the next part of the chapter. Okay. I hope you have copied it. See, after that, we are discussing the properties of nitric acid. So, what are the properties of nitric acid? First is when pure, it is colorless liquid. The impure acid is generally yellow due to the presence of nitrogen dioxide. See, when we prepare nitric acid, if that is 100% pure, then the color is colorless just like water. But at times it so happens the nitric acid splits into nitrogen dioxide whose color is brownish. As a result, the acid shows a yellowish stain. So if you see acid having yellowish stain, you should know it is because of the presence of impure nitrogen dioxide. Okay, this is part clear to you now? After that, nitric acid containing dissolved nitrogen dioxide is known as fuming nitric acid. So whenever you open a bottle of nitric acid, you will see some certain types of fumes coming out. It is the fumes of nitrogen dioxide, so it is called as fuming nitric acid. After that, in the gaseous state, nitric acid exists as a planar molecule with a structure as shown. See here, can you see the structure of nitric acid? Here we have nitrogen, it is bonded with oxygen. Here we have OH bond. So what is the bond angle? Bond angle here is 102. The bond angle between hydrogen, oxygen, nitrogen is 102, and the bond angle between nitrogen and both the oxygen is 130 degree. Okay, and there we have seen the bond length 140.6 pm, and here it is 121 pm. Okay, this is how the structure of nitric acid looks. Okay. Now, see, in the aqueous solution, nitric acid behaves as a strong acid and gives hydronium ion. What is hydronium ion? That is hydrated water ion. So that is called hydronium ion, and it also gives us nitrate ion. Okay, I'm giving you 2 minutes time. Just copy it down. I hope you have copied it. Okay, now we are moving to the next part of the chapter. The next part of the chapter we have over here is reaction of nitric acid as an oxidizing agent. How does nitric acid behave as an oxidizing agent? See, nitric acid shows oxidizing nature because it has the highest oxidation number of nitrogen, and it can actually get reduced to the lower oxidation state. See the first reaction. See the first reaction of nitric acid, that is nitric acid is a very strong oxidizing agent and it attacks actually most of the metals. Just see this reaction. Copper with nitric acid, it forms copper nitrate, nitric oxide plus water. Copper plus nitric acid can also form copper nitrate, nitrogen dioxide plus water. See the reaction. If the nitric acid taken is dilute, it forms copper nitrate and nitric oxide. If the nitric acid is taken concentrated, it forms copper nitrate as usual, and it forms nitrogen dioxide gas. Next reaction, see same type. Zinc with dilute nitric acid will form zinc nitrate, water plus N2O. Zinc plus concentrated nitric acid, that will form zinc nitrate, water plus NO2. Okay, so metals such as chromium, aluminium do not dissolve in nitric acid. Okay, because of the formation of passive film of oxide on the surface. Because of the formation of a passive film oxide on the surface. After that, we have the oxidation reaction of non-metal. So sulfur is oxidized sulfuric acid. Okay, see the reaction. You can see the reaction, that is oxidation of sulfur. When sulfur is made to react with nitric acid, it actually forms what? Sulfuric acid, NO2 and water. Okay. Now next reaction is the reaction of carbon with nitric acid. When carbon is made to react nitric acid, what are the products we get? We get carbonic acid. Okay. Now next reaction we have nitric acid plus iodine, it forms I2O5. Okay. See the reaction, iodine gets oxidized to HiO3. Okay. Now, in case of phosphorus, it gets oxidized to phosphoric acid. These are some of the important oxidizing reactions of nitric acid. These are some of the important oxidation reactions of nitric acid. Okay, just copy down these reactions. After that, we have next property, that is the brown ring test of nitric acid. See, you people will perform you people already performed in your practical the brown ring test of nitric acid. By this brown ring test, we can easily identify the nitrate ions. In brown ring test, what we do, first of all, we make an aqueous solution of the nitrate salt in a test tube. For the brown ring test, we make first of all an aqueous solution of nitric acid separately in a test tube, right? After that, what we do, we make a fresh solution of ferrous sulfate in another separate test tube. We make a fresh solution of ferrous sulfate in another separate test tube, right? After that, what we do, we actually add the ferrous sulfate solution. We add the ferrous sulfate solution separately. We actually add the ferrous sulfate solution separately. Okay, when you add the ferrous sulfate solution separately, what we get, we actually get a brown ring. This ring is after the sulfuric acid is added. This is the brown ring formation. Okay, this is the brown ring formation, that is, it is a complex, and the complex is pentaquoferrous nitroxide. Okay, pentaquoferrous nitroxide. After that, we will discuss about the next element, that is phosphorus. Now see, phosphorus shows two of the allotrophic form, that is, it forms white phosphorus, and the next one is the red phosphorus. Now we will discuss about the difference in the properties of the white phosphorus as well as that of the red phosphorus. Okay, see, the first important thing is that we will do the comparative study of the white phosphorus as well as the red phosphorus. Okay, see the first important thing, white phosphorus is a translucent white to waxy solid. On the other hand, red phosphorus is iron gray lustrous powder. It is a iron gray lustrous powder. Next property is that white phosphorus has a garlic smell, but this red phosphorus is odorless. Next important property, the physiological action is that it is poisonous in nature, it is non-poisonous. It is poisonous, it is non-poisonous. After that, next part is the solubility. It is insoluble in water but soluble in CS2. It is insoluble in water as well as CS2. It is insoluble in water as well as CS2. So up till the solubility point, you just note it down. After that, we move to the next part of the chapter. Okay. Okay, children, before we finish today's class, we have discussed till the solubility. We'll discuss the further properties in the next class. Before we finish, I would like to summarize what we discussed in today's class. In today's class, we have discussed the properties of two important compounds of group 15 nitrogen, that is ammonia and nitric acid. We have discussed the preparation, both the laboratory preparation as well as the industrial preparation. We have also discussed about nitric acids and its preparation properties and how nitric acid is manufactured both in laboratory as well as in the industry. So these are some of the reactions we have discussed till now. We will continue with the next part of the chapter in the next class. Till then, children, goodbye and have a nice day. Thank you.